Hello, everybody, and welcome back to TARTLEcast. In honor of springtime, Jason, I want to talk about the bees.
Yes, Alex. Remember that Tim McGraw song, Down on the Farm?
Yeah.
Yeehaw!
Oh, man. You gotta love country music sometimes. There's a lot of good things to learn from that.
Yeah, my tractor sexy.
You know?
I love that song. Okay, enough of that. Let's talk about this new landmark study shows soil pesticide reduces wild bee reproduction by 89%.
And here's a very interesting point. And I want to use this as a metaphor for data before we even get into this. Is that a lot of things in life, we only focus on what we can see. But a lot of the vast majority of life that is interacting with us are things we don't see. For instance, just even in forest, the mycelium. It's one of the largest organisms on Earth, but you never see it with your eyes. It lives underneath the soil. But it connects all the trees, the plant life, flora and fauna together, right? Through this little chemical interaction happening beneath the soil. It's that important. And when we are working with data, we typically only work with data that we see, things that we choose to observe because it's the only thing we're recognizing. But we need to start to look for those unknowns, those things that we didn't even know were involved in that system or that were having an effect on it. We have to search for those things that have been hidden or test our own perspectives that may be warped to the things that are just strictly right in front of us. And when we look at these bees, when you say bee and it comes to mind, like they talked about in the article, you only think of the hive. Think of that honeybee flying around, right? Going to that big nest, have the queen bee, all that other stuff. But a majority of bees around the world live underground. And they're the ones that continue to pollinate, but they live in a world completely unseen to you. We need to look at that as a sense of that metaphor for the protecting this world, because much of how we are poisoning the bees, and we find it here in the study, the ground bees, it's much like what we're doing here with the earth. Because we're not paying attention to the unseen aspects of it, we think it doesn't exist. And the data in the studying only goes towards a very specific, acute amount of things that are receiving that focus. But in reality, are only a small, small piece of all the things that come together to support that system.
Yeah, and it's when you look at the article, it's sad to see us take these labs and chemicals and then turn around and say, "Oh, okay, there's a hole in the ground. Let's just dump." I remember there was an old thing back in the from the South. You dump gasoline or diesel or something in the bee's hole. Yeah. And I know like wasp and hornets and stuff like that, but there's just this disregard for our ability to be able to protect with our responsibility. And we talk about this with the Big Seven, but when we look at this planet as a whole, and I think, you're so right, because we could take this and push this back to data and understanding not just the privacy of our data, but in understanding how it's being used. Yeah. And then how these big tech companies are basically just putting gasoline in a hole and not caring what the outcome is. No. Because all it is about profit. Yep. And that's the only concern.
It's the only short-sighted thing that you can see, but it's not everything else that's affected with it. Why look at it? This right here, what we're talking about, is a metaphor of the human perspective right now that we're currently faced with. And that's what we want to discuss. And I think the data of this article with the bees is very pertinent to that idea.
So they wanted to look at understanding how pesticides affect bees, and then testing domesticated honeybees, and more recently bumblebees. Mm-hmm. That's largely because these species tend to be easier to work with in lab conditions. There's a lot of universities that have beehives.
Control groups. Everybody wants a control group. Humans just want to control things.
So, and I don't know how to pronounce this, neonicotinoids.
Neonicotinoids
are a family of pesticides which have been used in farming across the world. Their chemical structure resembles nicotine, and they're designed to kill crop pests by targeting the insect nervous system.
What happens when I take a drag of a cigarette?
Right.
It has an immediate effect on my nervous system, right? Get all jacked up for a second.
So if you did 1,000 cigarettes...
I get the nicotine buzz, but if I take 1,000 cigarettes in concentration onto a nervous system of a bumblebee,
right,
or whatever this bee, a squash bee, that is going to just destroy it. That's literally nerve gas at that point.
Yeah, these neonicotinoids can be sprayed on plants, but are mostly commonly used to coat seeds.
Neonicotinoids.
Yes, there you go. Good job, bro. I'm so bad. Since their introduction in the late 1980s, so this was introduced in the 1980s, robust scientific evidence has emerged to suggest these chemicals impair learning and memory, foraging behavior, and pollination in bees.
Yeah, so I got bees just like going all squirrely in the air because I was coating my seeds to try and protect them.
Yeah, and this is the sad part whenever you begin to look at this. Working over 3 years, the researchers mimicked the conditions on a real farm by growing crops of squash plants in large polytunnels. Before planting, these common pesticides were applied to the seeds and later the leaves. While one chemical called, and I can't pronounce this one, imidacloprid, was applied to the soil, this is used in Ontario to control the striped cucumber beetle.
Yeah.
So now we're trying to control a beetle, and in turn we're affecting, it's just this thing over and over and over again.
You're killing the thing. I'm trying to stop a beetle, but I'm killing something that I don't see that is, 86% of all bee pollination that happens comes from bees underground.
Yeah, and there was a hoary squash bees, a ground nesting species that were found on the farmland, and they're here all throughout North America too. These squash bees are uniquely suited to pollinating the flowers of squashes, pumpkins, and cucumbers, thanks to special leg hairs that fit the size and shape of their pollen grains.
How cool is that?
I know, isn't that cool?
I think that's amazing.
They tend to forage earlier in the day than most bees do to match the early morning flowering of these plants. So this is evolution working, evolving. Yeah, the species
is working with nature.
Yeah,
I think humans need to learn a little bit of something with working with nature rather than fighting it all the time.
The researchers studied nest building, foraging, and reproduction of these bees and found that this chemical in particular, one of the most widely used worldwide, had a devastating effect on all aspects of squash bee life. Compared to insects living on untreated cropland, the hoary squash bees exposed to this chemical in the soil created 85% fewer nests.
Isn't that amazing? The data is showing that there's imagine if I released a toxin in the air
right
over here right now, and it killed off 85% of people in their homes. Imagine that. People would be in a freaking panic.
Well, think about this. It left 5 to 3 times more pollen in harvest and produced a staggering 89% fewer offspring. So what if we did 5 to 3 times less work because of this being released?
Yeah.
What would happen?
Imagine the economy. 5%, just a total 5% reduction in the economy, it'd be crippling.
And then a staggering 89% fewer offspring. So then all of a sudden, 90%, almost 90% of the people just...
We stop having babies.
Yes.
We stop going to work. Oh, and we've killed off a huge majority of people. They don't want to stay in their homes. So you displace people. I'm going to displace you. You can't work, and you're not having children. I'm
going to impair you mentally...
I'm going to impair you mentally.
With impair learning and memory.
And so I'm going to be walking around drooling, just like looking up at the sky, and I'm like around the streets, totally whacked out of my mind on this insane nerve gas of nicotine cloud that's come over and hit me.
And this is what we're doing to bees.
Yeah.
If we would look at it, it's beautiful, Alex. If we would look at it in that perspective and just put ourselves in their shoes, and I know that sounds silly because you're just thinking, well, it's just a bee. But it's more than that.
We haven't even learned from their efficiencies.
They said that bees, if bees go extinct, we're extinct.
Yeah, if all the bees are gone, I mean, there's no pollination and there's not enough wind to cross-pollinate. That's going to be a problem.
Try pollinating by hand.
And by the time another species can come over and take its spot, I mean, we're going to be out of a pretty big chunk of human beings at that point.
So what is the answer to this is the question I always have. And I know scientists are working on this diligently, and I want to thank these scientists that do these researches and come out there and brave to make these reports. Because these scientists that are collecting this data and putting it out there in a non-biased way are data champions.
They are data champions. They're just saying this is what has happened. Did they say that the people once in here the whole time using the pesticides are bad people?
Yeah, exactly.
Was that ever stated?
No.
No, they're just stating this is what's happening. This is the outcome. That's all. Oh, by the way, you thought this was the only thing? No. There's another 86% of all the bees that live underground. No one's been focusing on them. This is an amazing data champion. These are people just telling it how it is without any sort of dogmatism or political bias that sits behind it. They're just trying to tell the truth so that it brings awareness to it so that people like you and I have the ability to share these great stories around data and research with the rest of the world.
Yeah,
and also use it as a metaphor to what's going on right now with, our data.
So let's shout out this guy, Philip Donkersley, Senior Research Associate in Entomology at Lancaster University.
Yeah, thank you very much.